All right, so this idea of a limit. The first unit, the first chapter we talk about is all about limits. What a limit is. A limit is the thing that's, you don't hear about it in Math 1, Math 2, Math 3, pre-calc, trig. You don't hear about it in those classes. It's a calculus thing, and it's the foundation of calculus. That's why we start with it, right? So the foundation of all calculus is this thing called a limit. So what the heck is it? Well, the best way to explain what it is these two things, these two stars here. Okay, so imagine you had a function. Let me get a separate sheet of paper here. Let me go back up. Okay, so imagine you had a function. Y equals x minus 4, right? Imagine you had something like that. Okay. You could, it's a linear. It's linear because x is to the first power. Okay. So what you guys have done in Math 1 and Math 2 and Math 3 and pre-calc is plugged in numbers, right? So if I said, when x is 4, what is y going to be?
0.
Yeah, you plug it in, right? You plug it in, 4 minus 4 equals 0, right? So when x is a certain number, y is a certain number. What a limit does is says, okay, I don't want to know when x is 4. I want to know when x is getting close to 4. So as I pick numbers that are getting closer and closer to 4, so 1, 2, 3, 3.1, 3.2, 3.3, 3.4, 3.5, 3.8, 3.9, 3.99, 3.99999. As I plug in those numbers, what is this guy? What is y doing? What is y doing? The easiest way to figure out a limit is by plugging it in, right? So as I plug in numbers that are closer and closer to 4, y is getting closer and closer to 0, like we said, right? 0, right? That's a limit. So we're not necessarily plugging in numbers for x. We're plugging in numbers that are approaching 4, approaching that number, okay? So that's what a limit says. A limit says is as x is approaching some number, what is y doing? Okay? Like I said, the easiest way is to plug it in. If you can plug it in, plug it in. Okay? So we'll talk about that next week about about equations and stuff like that. Today we're just going to look at graphs because I think graphs is the easier place to start. Okay? But that's what a limit is. It's always the y value. A limit, whenever you get an answer for a limit, we're going to get a lot of answers. It's always just the y value. We look at the y. Okay? So you're going to see things like, let's go down to the first graph. Let's look at this guy here. This V looking thing. So this is limit notation. This is limit notation. So you see the word LAM for limit, right? That means it's a limit problem. And then you have X arrow 3. That means as X is approaching 3. So as X is approaching 3. Well, X, this is the X-axis, right? So as X approaches 3, so X is going to come from two ways. It's going to come from the left and it's going to come from the right. So as X approaches 3, the function in this case is just a graph, right? The function in the example I gave you was x minus 4, right? So today we're going to see graphs today. So today we're only going to be talking about graphs. So as X approaches 3, the limit for the function is 2. That's the answer. That's true. I'm going to explain why it's true. Okay, so let's go to the function. The function is the V, the graph, right? So I'm going to start from the left side. So the left side of the graph is right there, right? That's the very left of the graph. So as we get closer and closer to 3, x equals 3, What is y doing? That's essentially what the question is. What is y doing? Okay, so let's start. So we start here, and then we're getting closer and closer to x equals 3, right? Where do I end up when I get to 3? 2. The y value is 2, right? So from the left side, from the negative side, we say, because it's coming from the left, when x gets closer, when the function gets closer and closer to 3, y is 2. That's why it's 2. Now, for 2 to be the answer, I have to be approaching the same y value from the other side. So let's go from the other side. So the other side is the positive side, okay? Because it's coming from the bigger numbers. Okay, so as we go this way, 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 are we approaching the same y value from both sides? And that number happens to be 2, which is why the answer is 2. Okay? Math is always easier when it's visual, so that's why I start with graphs, because graphs are all visual. There's not calculations. I don't plug in any numbers, right? You're just looking at the graph. Okay? All right, let's look at the second example. So the answer is 2 for this one. We know the answer. The answer is going to be 2. So the limit for g is the graph here. Not only is it the parabola, but it's also the dot and the whole, right? It's everything. Okay, so as I approach 3, I'm approaching 3 again, right? So as x approaches 3, that's right there. Let's do the same thing. I'm going to start from the left side, the negative side. So as x approaches 3, as I'm getting closer to x equals 3, which y value am I getting closer to? 2. Now for 2 to be the answer, it also has to be true from the other side. So let's go to the other side, the positive side, the right side. So we start up here, and I go down, and I'm getting closer to y equals 2, which is why the answer is 2. Okay? As I'm getting closer, that's a limit. A limit is as I'm approaching, as I'm getting closer. I'm not asking for the answer at 2. I'm not asking, or sorry, at 3. I'm not asking for the answer at 3. I'm asking for as I'm getting closer to it, right? All right, let's try the next one. So the next one, the answer is also 2. And this one is as x approaches 3. Okay. H of x is a straight line. It's a straight line going downhill. It's a negative slope. All right, so let's start from the left side. So as I get closer and closer to 3, what is y going to be? So as I get closer and closer to x equals 3, what is the y value getting closer and closer to? 2, right? Now let's go to the other side. As I get closer and closer to 3, what is the y value getting closer and closer to? 2, which is why the answer is 2. All of those had same answers, I was approaching the same number, okay? It won't always be 2. The answer won't always be 2, and I won't always be approaching 3. But they gave you 3 examples that were similar just to kind of differentiate them, okay? All right, that's the idea of that's how to solve a graphical version of a limit, okay? So we say, when we're reading this, we say the limit of f of x as x approaches 3 is 2. That's how we read it, okay? All right. Okay, so now let's go down to one that's not yet solved. So this is the first one we're going to do. So g of x. G of x is kind of funky. It's got different things, right? G of x, it's got a piece out here. We call this a piecewise function. We call this a graph piecewise because it's got a bunch of different pieces, right? It's got this piece over here, and then it's got this piece, which looks like part of a parabola, and then it's got a dot up here, and then it has this part down here. It's got like a bunch of different pieces, so we call it a piecewise. So the first one is as x approaches 4. So as x approaches 4. Okay, so 4 this time. 4. What is y doing? Remember, a limit always means the answer is always going to be y. What is y doing? We know x is getting closer and closer to 4. What is y doing? Okay, so let's start from the very, very left side. The very, very left side, the point that's the very most left is this dot right here, -2, +2. So that's where I'm going to start from the left side. And I'm going to go to the right until I get to 4. Okay. So I go here. I have to stop at the empty dot because I ran out of room. So where do I pick up? At the solid dot. So I'm going to pick up at the solid dot. I'm getting closer and closer to x equals 4. And I'm there. So as x approaches 4 from the left side, what y value am I getting? 1. Now let's see if that matches from the other side. Well, the other side, the very rightmost dot, is 6, -1. So that's where I'm going to start there. And I'm going to do the same thing, except I'm going to go opposite direction. So I start here, and I get closer and closer to 4 from the other side. Which y value am I approaching? Same number, right? I'm approaching the same y value from both sides. The green and the yellow approach the same y value from both sides. So we say that's the limit. The limit is +1. Because the y value was 1. Where the green and the yellow meet was both the same y value. Okay. All right, let's do the next one. So I'm going to erase some of this because they change the y value or the x value. Okay, so the next one is +1. So +1. Okay, that's the next y value. So I'm approaching +1 from the left side and from the right side. So let's start at the left. Very, very left. Very, very left is right here. Same, very, very left. I'm approaching +1. So I go and I go, which y value am I getting closer to? 1, right? 1 again. Now I'm going to go to the other side. I'm going to start at the rightmost down here at that dot down there. And I'm going to do the same thing. What y value do the green and the yellow meet at? Kind of a trick question. So the green is going to meet at 1, right? The green meets at 1 here. Where's the yellow going? 4, right? They're meeting at different spots. Well, if you're meeting a friend and you're by the 80s and your friend's by the 20s, are you guys going to meet? Not there, right? So what we say is if they don't meet at the same y value, there is no limit. We say the limit does not exist, or DNE. DNE. How can I meet you somewhere if you're there and I'm here, right? So when they don't meet at that x value, green says I'll meet you at 1. Yellow says I'll meet you at 4. They don't meet, no limit. Does not exist. Okay. Okay, try letter D. We'll skip C for right now. We'll come back to it, but I want you to try letter D. Try letter D, see what you get. I'll give you a hint. Letter D has an answer. It's not DNE. Okay, letter D will have an answer. Okay, so letter E is -1, but it's only coming from the left side. -1 only coming from the left side. So as I come from the left side, I start here, and as I get to x is -1, I end at y equals 2. So since it's only from the left side, it's going to be +2. F is the same problem. I'm just coming from the other side, right? Coming from the other side. So come this way, keep coming, stop. I'm at a different y value. I'm at -1. So what's the answer to G? D and E, yeah. E and F need to be the same number for G to have an answer. Since it doesn't, it's not. And then H, we talked about it. When X is -1, there is no dot. There's 2 open dots. That doesn't mean answer. So we would say no solution here. No solution. There is no solution at X equals -1. Where else? Where else would there be no solution?
6.
Yeah, X equals 6. Yeah. Look at X equals 6. It's what we call an asymptote. Asymptote means it's just there's no answers anywhere when X equals 6. Yeah. Where else? There's a couple other spots.
2.
2, there's no answer. How about 4? Is there an answer at 4? 5, 7. It's got a lot of no solutions. So if it said H of 2, you would say no solution. If it said H of 4, no solution. H of 5, H of 7, those two. Okay. Okay, the last page. The last page is just some more practice. Example number 3 is look at the graph. Here's on example number 3, there could be multiple answers, not just one answer. So you could have one answer and the person next to you could have a different answer and you'd still be right. So A, give me a limit that exists. Create a limit. So when I say create a limit, that means you're going to have a limit as x approaches something for f of x. So what you got to figure out is what x value are you going to put in, which y value, to make it a limit exists. B is the same thing, but you're only coming from the left. So give me a left side limit. C, coming from the right. D, give me a limit that wouldn't exist. So give me problems. A, B, C, and D are you're creating the problem. You're creating the problem. Right? Using this graph, you're creating a problem and then answer it. So all of these are going to be the limit as x approaches f of x equals. So you guys are coming up with, I'll use a different color. So everyone will have the same black, but you might have different numbers you filled in for the blue and the pink part. Okay, so the first one is give me a limit that exists. Then give me a left-sided limit for any number. Give me a right-sided limit for any number. And then the last one is give me a place where a limit doesn't exist. All right. Okay, so I think it doesn't matter which one you start with, A, B, C, or D. I think, though, it would be easier at D. D would be probably the easiest place to start because there's only so many places a limit won't exist, right? So we know the answer to D. So we know the pink part is going to be D and E, right? That's going to be D and E because it doesn't exist. So let's look at the graph. There are 3 spots that I see that a limit wouldn't exist. Where's one of them?
5, 2, and -1.
So 2, yeah, 2, definitely at 2, there's a jump there. -1, there's a jump there. And at 5, there's a jump there. Any of those would work. Any of those would work. So any of those would work here. You could have in the blue -1, 2, or 5. Okay. So where does a limit exist? Everywhere else. Everywhere else from -3 to +9. So you literally could have put any number from -3 to +9 that isn't -1, 2, or 5. You could have put -2. You could have put 0, x equals 1, x equals 3, x equals 4, x equals 6, x equals 7, x. When I say x equals, I mean x approaches, right? You could pick in between. I could say 0.5, 1.5, 2.5, right? You could get like that, right? So for example, let's see, I'll pick -2. As x approaches -2, so as I come from one side and I come from the other side, I'm going to meet at -1, right? So the limit there would be -1. That's only one answer. If you have a different answer and it works, great. Okay. A left-sided limit and a right-sided limit. So since I use -2 for A, I'll use -2 also for these guys. So -2. Left-sided means you come from the negatives, right? The negatives are on the left on the number line. Think of a number line. Negatives are on the left, positives on the right. So left side would be negative. Right side would be positive. So at -2, left-sided limit would be -1. Right-sided limit would also be -1. Is that the only answer? No, absolutely not. Okay. All right. Then last question. The graph of f of x. What is the limit as x approaches 1? D and E. Yep, letter D does not exist. Because at +1, there's a jump here. Right? They don't meet. They don't meet. There can't be a limit. Okay. D and E. And that's it. That's the first lesson. Okay. So I'm going to show you a couple things since we got about 9 minutes or so. So I'm going to show you a couple things. First thing is, where do I put the notes? So let's say I wasn't here, or let's say I didn't get the notes. I need to get the notes. Where do I find the notes? Well, it's on Google Classroom, but I'm going to show you where.